Hey everyone, this is Umongus, and this is part 1 of my new programming series, Data Structures. Now there are various types of data structures, and for this first part we're going to be going through array lists, and then part 2 will be about a linked list, and then part 3 will be about a binary search tree. Well, to start, I first created an empty main program, and it has an array. Since we're using an array to represent a list in this case. And then there's another C file called element.c, and this is that element. It contains a type of struct called element. It contains an integer and then 2 pointers to the previous and next element structures. Well, this is actually going to be used for the linked list. As of now, we're only going to be dealing with an array list. Now, the main differences between a array list and a linked list is how they're contained, and with that it also comes with some advantages and disadvantages of each. The array list is better for quickly accessing an element that's in a certain part of the array. So let's say if you want to access element number 10 on here, and then it looks straight at element number 10 on the array list. Whereas for the linked list, you would have to iterate through, and that could take a long time for a large linked list. Now, a linked list, it contains pointers to a few different elements on there, such as a pointer to the first, and then when the element contains a pointer to whichever the next one is, and then it goes to that one. Now, while the array list is better for quick searching, a linked list would be better for inserting new elements or for sorting. Because, so right here you see a sorted array list, because see the number sequence goes 0, 9, 12, 19. Each number is larger than the last. And yeah, later on we're going to be dealing with sorting as well as searching. Part 3 is going to be about a binary search tree, and what that is that it starts off in the middle of an array list, and then it's a good way to search through very large arrays. Alright, so because if we were to insert an element into the array list, let's say insert a number of 75 into this spot right here, element number 3, and then if it has to be sorted, it will first compare 75 to the 19, and then it will switch places. Yep. But then inserting it also actually shifts these numbers afterwards. So let's say if 60 was element number 45, it would become element number 46, and that's going to require a lot of reassigning, and if doing that for an array that's very large, then it's going to take a long time. So for insertion, it's going to be better to do it with the linked list instead. So yeah, in a nutshell, array list for quick accessing, and then linked list for insertions. Alright, and for this episode we're just going to be dealing with an array list, and we may also include sorting the array list at the end. Alright, so over here you see we have an array called A list, and it's an integer array, 100. But yeah, since programs generally run each instruction pretty quickly, and so it only becomes a problem if we're working with really large arrays that contain, let's say, thousands or even millions of elements, which in that case, yeah, it's going to need some better methods. So as of now, we're just going to stick to a small array where everything's initialized to zeros, and then, as I've seen here in C programming, at least when done on this computer, initializing an array, every element is initialized to 0. Even though on some machines it seems they're initialized to some really random big number, which then you can set it to 0 later. But yeah, as of now, we're going to need the array and then also another integer representing the size, and that means how many elements are inside it. Now technically there's 100, but they're all just placeholders set to 0. That way when we decide to insert some of our own elements, it'll increase the size. And so let's say an array list of 5 elements and it's empty, and then if the size initialized to 0, and then now let's say if you decide to insert 10 in here, and then now the size is equal to 1, and then you decide to insert another element, let's say 5, the size becomes 2, and then this, let's say the array is much larger now, and then, you know, how about 1,000,000 elements, but then the size is still going to be 2 since we've only done 2 insertions. So that way if we ever do a search, then it's not going to do anything to all of these elements afterwards. They're going to be left completely alone, and then yeah. So we'll initialize size equals to 0, and yeah, right now let's create a function called void insert, and then it's going to represent us inserting a new integer. So let's say void insert int entry, and then also have to redeclare it up here. Alright, and then since the size starts off at 0, and then since how arrays work is that the very first element is called, well, its index is 0, and then the second one is indexed at 1, and then once we add our first element, it's going to be at index of 0 then. So a list size equals to entry. Right, so then, oh, and then we're also going to have to create one that prints out the contents of the array. So yeah, print array list, and you could make it print all 100 elements, or you could just make it print the number of elements we've inserted. But yeah, we're gonna start off for now. Let's print all elements. So int I equals 0, and then I less than 100, and then I plus plus, and then yeah, let's printf printing array, and then the colon and the new line, and then this. Alright, and then at the end of it all, it's gonna printf another bracket. And then, yeah, each element is going to be printf, and then let's add a space between each element, and then a comma, and then %d, with being the decimal of a list I. Alright, there. And then, yeah, for the size, you could replace this 100 right here with size if you just want to make it print every array that you've inserted. Alright. Oh, and another important note here is make it increase the size every time. Well, let's also add another, or you could initialize it to be a very large number, but we're not going to do that for this program. We're just going to stick to a small set of numbers. Alright, and then for inserting elements, it will be like this. Call the method insert from here, and then add the number you want to insert. So let's say you'll first insert 15, and then various other numbers, and by this point the size would have increased to 4. So now let's test our program. Oh, actually, here, also make it print out the array so that we'll know the contents afterwards. Alright, now let's test our program. Right, so it seems there's actually an error over here where the struct pointer should actually include struct before it, struct element previous, and then struct element next. And again, be sure to declare the functions at top first and then write them at the bottom. Alright, now, alright, and then yeah, every element initialized to 0, and then we've inserted these 4 numbers right here. So yeah, and then next, if we try, I'm going to try replacing the 100 in the for loop with size, and then save, then and yeah, it now works as intended. So we now have the output 15, 10, 5, 105, and that's the order in which we inserted each element. But now, next what we're going to do is to sort the array list so that it becomes in order 5, 10, 15, 105, and again I'll be doing it with the small array having only these 4 elements, because if we were to include thousands of elements, then yeah, sorting an array list is going to be even more time consuming than sorting a linked list. Alright, so now what we do is go into the insert function, and then after a list size equals entry, but before that we're gonna need to declare a few variables. Say int current value, prev value, and then int for index, and then is sorting, which is going to work as a boolean, and then set index to size, and then is sorting initialized to 1, because now we're going to want the list to be sorted after every entry. Right, so after it inserts the integer, and then if size is greater than 0, then now we're going to want to enter a while loop. While is sorting is equal to 1 and size, well, index greater than 0. Right, and then in this while loop, it's going to be for sorting. So curval equals a list index, and then prevval equals a list index minus 1, and then if curval is less than prevval, then it pretty much what it does is it switches them. So a list int now equals to prevval, and then index minus 1 equals to curval. Else it's gonna exit the while loop by setting is sorting to 0. Yeah, and also it'll have to de-increment index by 1. And now let's test the program. Alright, now it works, because if you remember, we added the numbers in this order: 15, 10, 5, and then 105. So now, once it added the 10 and then it sorted, and now for a more thorough visual representation, we can try to make it print after every entry. So yeah, let's save, and then go into Windows Terminal and then recompile. Alright, and yeah, now it gets put in order every time. Alright, and this is going to be it for episode 1 of our data structures, and part 2 is going to be about a linked list, and then part 3 is going to be about a binary search tree. Alright, well, see you then.